In college algebra, we wrapped up our quadratic equations notes. We're way down here working with quadratic formula. We have been talking about quadratic formula quite a bit, but we haven't actually gone over it yet. So here we are, number 6, we're going to go over it. This is all based on the idea that we have ax squared plus bx plus c equals 0. So on number 6, naturally, a is 2, b is negative 6, and c is 1. So all we need to do is plug those 3 numbers into the equation or the formula on the left, right here. Simplify. We'll be good to go. All right, so we know x equals negative b, which is negative 6, negative 6, square root of b squared minus 4 times a times c, all over 2 times a, which is 2. So take a moment, hit pause, make sure you're okay plugging into that formula on the left. And then you want to simplify and go very slow. Don't mess up on a sign. So we end up with that. And then we get this. Now at this point, while I would prefer you to simplify the radical nicely, I'm actually okay with you going all calculator. But I'm going to simplify it nicely. So we're going to go plus or minus 4 times 7. That turns into 2 square roots of 7. The 6, the 2, and the 4, those are all divisible by 4. Remember that square root of 7? It's kind of like this. Whoops. That 2 square roots of 7, it's like the same as that. So I ignore the 7 for a second, and I want to reduce this fraction. The 2, the 6, and the 7 are all divisible by 2, so I can rewrite this and be done with an answer like this. All right? Another choice, though, if you want, is to type that into the calculator. So we can go 3 plus square root of 7 over 2 and see what we get. And we can go 3 minus square root of 7 over 2 and see what we get. So on that first fraction, you get 2.82, and on the second one you get 0.18. I am a-okay with you writing what I circled first, or you can write these 2 answers, or you can, I don't know why you would, but you could write it like this. Any of those 3 circles are acceptable answers. Notice the bottom right, the 2.82 and the 0.18, you could have gotten those from that fraction right there. So while I would prefer you to write it with the first circle, with the square root of 7, I mean, you can go with decimals if you want. Doesn't matter to me. All right, number 7, it's a little bit different, and that's because step 1 right here is not done. Notice this equation is not set equal to 0. Look up at number 8. It was set equal to 0 right there. I need to set number 7 equal to 0. So I'm going to move everything to the left side. So I'm going to rewrite it as x squared minus 2x plus 2 equals 0. And now I know a is 1. B is negative 2, and C is 2. And I can plug into the quadratic formula. If I were you, I would hit pause and see if you can do it without me. So let's see, we get negative 2, negative 2 squared, all over 2 times a. So we end up with positive 2, 4 minus 8. Ooh, that's going to give us a weird answer. That equals 2 plus or minus negative 4, square root of a negative. Can we do that? 2i. No way to use the calculator on this problem. That's why it's a good habit to be familiar with your square roots. Final answer, you could take it all the way to this step right here. If you wrote it this way, you might lose a point, but I would prefer you divide them all by 2 and reduce it down to 1 plus I or 1 minus I. All right, let's look at the discriminant inside of the radical. I am looking, let's change colors, right here, inside the radical, under the radical, whatever you call that. That is called the discriminant. If the value under the radical is positive, then I have 2 real solutions. Look, that happened on number 6. These are 2 real solutions. Sometimes that's all they ask, is what type of solutions will you get. The 7 is positive, or sorry, the 28 is positive, so you have 2 real solutions. You could get equal to 0. It's kind of redundant there. And then you have 1 real solution. Or you could get a negative, like I did on number 7. And then you have imaginary solutions. So let's give number 8 a try. It's a brand new problem. It has all kinds of writing next to it, so let's delete all that. And we want to solve for the discriminant. So I know A is 4, B is negative 8, and C is 1. And I'm plugging into just this part of the quadratic formula. Very simple. Don't overthink this. And then we're going to match the result with one of the 3 scenarios right above it. So I have negative 8 squared. And by the way, if you can do this in your head, I need you to, at the minimum, write what I'm writing right here. So if you see that that result is going to be positive, greater than 0, then you can stop right there, and you can write 2 real solutions, and I will give you full credit. But I need to see at minimum what I have written right there. I would recommend going maybe a step further. Hopefully at this point you for sure know it's positive. Maybe actually type it in. And now for sure you know it is scenario number 1, 2 real solutions. All right? All right, let's look at a word problem. This one's kind of depressing. I'm going to scroll past this sad story here. And we're just looking at crashes. Let's just call these crashes. And age of drivers. So here we have a graph. Next to the graph, this is really typical of a lot of the problems we work. This is real world data. Like actual data. And then this equation is called a model. It's used to predict things. So some statistician in the government took all that real world data, they did some stats, and now we have this prediction formula right here. Think of this as a formula. And down here, they're saying if we have 3 crashes, I need to retype this thing and just call them crashes. That means n equals 3. What is x? So what you need to do is plug in the 3 in place of n. Write the rest of the equation. And go through your 2 steps to solve a quadratic equation. I need to set it equal to 0, so I need to get that 3 on the right side. And that's pretty quick. Now we know what A, B, and C are. I know A is 0.13. I know B is negative 1.19. And I know C is 2524. And I can plug into the quadratic formula. So let's solve for x. Maybe hit pause. See if you can plug it in correctly to the quadratic formula. You really need a calculator for this one. So when you start typing this in, go really slow, take it in small pieces. All right, so when I type in just under the radical part, I get 0.10362, and then I square root it. And I get 3219. So for one of the answers, I'm going to add the 2 top numbers and then divide. And then I'll subtract and I'll get my other answer. So when I do that, I get 33.4. And when I add the 2, I get 58.2. So those are my 2 ages for the first question. By the way, where could I write this? This fraction right here, I see people mess this up all the time. If this is your fraction, be careful on the calculator. Do not type 119 plus 3219 divided by 026. Those are not the same thing. If you want to use the calculator and do it in one shot, you need to wrap that in parentheses on the top or press Control Divide. If you press Control Divide, you're going to get a nice fraction and then you can type it. So be really careful at typing that fraction in there. All right, last question. How well does the formula match the graph? So we got 33. That's like right here, right? And we got 58. That's like right here. I think it does a pretty good job. This is age given 3 crashes. I think the model, the equation, does a pretty good job. It's not going to be exact. It's not going to be precise. So I don't want to scroll away from this. I'm going to write it in the top left. The model does a good job. Now I realize this is about something else, but I'm just going to say crashes. Of predicting crashes and ages when looking at the graph. Values, or let's say ages, because that's what we're talking about. Ages are very close. For n equals 3. All right, that's all we did. See y'all later.